All right, this is day 2 on 4.7, and I'm going to skip some of the warm-up problems, so this will be a short recording, okay? These first 3, just tell me, would you use law of sines or cosines? I'm not going to bother to solve them. I'm going to assume you guys could do it. If they want us to find RT over here, what are we going to use? Law of sines. Everybody okay? Yeah. If we were doing number 2 and we wanted to find angle B, what would we do? Law of cosines, and it would look like this. Can anybody tell me how you would type that in? 10 squared, subtract the 5 squared and the 7 squared, and then divide by this mess. Whoa, somehow I don't think there's 2 cosines, or 2 equal signs in there. So you divide by that parenthesis, and then do second cosine. Do you need me to do that one so we can check it? We're good? Yeah. All right, I'm moving on. Law of sines or cosines to find that side? Don't have anything across from anything, right? Got to do law of cosines. So it would be x squared equals 40 squared plus 49 squared, etc. Yep. All right. This is an application problem, which a lot of the homework is, so let's check this out. It says there was a lamppost and it was straight up and down till it tilted back 2 degrees. So now what is the angle it's making with the ground? 92 degrees. Can we find the angle up here then? 180 minus 92 and 43, 45 leaves us 43? No? Yes? Okay, thanks. I can't read those numbers very well. My bifocals aren't happy. All right. We're supposed to find the length of the lamp post, which is this. So law of sines or cosines? The sine of 45 degrees is across from our magical x here. In the same way that what? Sine of 43 is across from 25. There you go. Okay, can we have 2 possible answers? When do we look for 2 answers with law of sines? Yes, when you're looking for an angle. We're not looking for an angle, right? We just found the length of a side. We're done. All right, Kieran's formula, this is new today. This is if you're given 3 sides of a triangle, okay? This is like the most useful formula, but it's one you'll never remember, so you'll have to Google the rest of your life probably. But you're finding the area of something. You just went out with a yardstick and measured the 3 sides of a triangle. That's pretty real life, right? If you had a triangle, you had to find the area, you could take a tape measure and measure the 3 sides. Okay? Most of us, to get an exact angle to the nearest 100th of a degree or something, yeah, we'd be stuck, right? I don't have something that measures degrees very well. I just got my little plastic protractor. But I can use my tape measure to measure the sides. So to find the area using the sides, you have to find what's called the semi-perimeter. It means halfway around. Does that kind of make sense? Yeah. Halfway around, okay? So you're going to take the 3 sides, add them up, and take half. That's S. And then you take, look, this is weird. You take S times S minus each of the separate sides, and then you have to take square root. Crazy formula. It's kind of working backwards from law of cosines. There's some crazy business involved here. Okay, we're going to do this example real quick by hand, and then I'm going to show you a little bit of a shortcut on the calculator. Not really by hand, but I just mean with our calculator. What's 36 plus 20 plus 22? 78 divided by 2, the semi-perimeter is 39, okay? So you would have 39 times 39 minus 36 times 39 minus 20 times 39 minus 22, which would be 39 times, whoa. 39 times 3 times, what is that, 19 times 17? We would do this all on our calculator because we're too lazy anyway, but that's as far as I'm going by hand. 39 times 3 times 19 times 17 is 37791. I square root. And I get an area of 194.4. Yes, no, maybe? And maybe I have a hot mess. I have no idea what I just did. Okay, we're going to go with, that was that one, right? All right, I want to go back or forward. Yep, that's what we're going to do right now. Thanks. All right, guys, we're going to use the calculator, a feature on the calculator to try to save a little time and energy when we do this one. I'm going to do number 6. Everybody got this? Find the semi-perimeter. So type this and then divide it by 2. Remember, you have to add before you divide. I got 15.5. Now, you could type this 15.5 times 15.5 minus 14 times 15.5 minus 9 times 15.5 minus 8. Or you can store 15.5 and then you'll never have to type it again for this problem. What I want you to do is find this feature. It uses this store button on your calculator. You're not going to put 67 into X. You're going to put, what was it, 15.5? So do 15.5 and then that STO button, which will bring a little arrow up on your screen, and then hit the X button up at the top. So, here we go. 15.5 store into X. You hit enter and all it says is 15.5. But now every time you type an X, you get a 15.5. So what we're going to do is we're going to type X parenthesis X minus, what were the numbers, guys? 14. Close parenthesis, open parenthesis, X minus, what were the other ones? 9 and 8. Close parenthesis, open parenthesis, X minus 8. Still a pain in the neck, but was it a little less typing than putting 15.5 in place of all those X's? All right, I got 1100 and I still got a square root, right? You could have put it all in the square root the first time. I got 33.7. Did anybody else get 33.7 after they finally found the area? All right, let's try one more time using, this was square feet, 33.7, is that what we just said? By the way, I need you all to hear this. Is everyone listening? It doesn't matter what's stored in X. Unless you're typing X on your home screen, it will never matter. So don't freak out and go, how do I get that out of there? It doesn't matter, okay? As soon as you actually go into the grapher and use, I think it stores your latest X value from your graph in there, okay, or something. So don't worry about it. Unless you're typing an X onto the home screen and using it as part of a calculation, it doesn't matter what's stored in there. If you are, then obviously you want to store a new value into X before you use it. All right, let's try this one. What does this one come out? I think S is what? Anybody add these up already? We got 16.5 this time. So I'm going to store that into X. Let's go going to become x, and then on my screen I'm going to type x times x minus 8 times x minus 12 times x minus 13, and then at some point I'm going to square root that answer. Okay, I got 2208 here. Anybody else? Before I square rooted? And then after I square rooted, I got basically 47. And that is, what's the label? Square centimeters. Okay. Everybody all right? You get the store thing? It's just to help with that crazy formula. All right, last one. The formula for finding area of a triangle given two sides in an angle, or a way to find two sides in an angle, okay, is 1/2 the length of a side times the length of the other side times the sine of the included angle. It has to be the included angle. All right, again, this is a shortcut from saving us from having to do 1/2 base times height. Because if we only know a couple of the sides and we don't know the height, we'd have to do a whole bunch of trig to find the height. So this is a shortcut, okay? Guys, I'm taping here, so let's just get the last couple examples done. If we have this triangle, I can't write, RST, and we have a 50-degree angle here, side S is 12, side T is 14. The area is just 1/2 side times sine of 50. Which is 64.3 square yards. All right, this one has a star by it though, because can I use this formula right now? No, but can I find this missing angle and then use law of sines? This is a 45-degree angle because it has to make 180. And then I need to find one more side. If I find, say, that side, sine of 45 is across from x in the same way the sine of 25 is across from 14. I think I get 23.4 for this side over here. And then I now have enough information to do this two sides and an angle in between. So the area would be 1/2 one side times the other side times the sine of the angle in between. Anybody 153.9 feet squared? Did anybody do that or not? Did you get 23.4 when you found this side? Okay. Okay. There are some more applications on here. We don't need to do all of them. Let's just do this one because this concept, this number 11, guys, this concept is used over and over. Students want to drop this height down and say it bisects the 500. In order for it to bisect that 500, 250, and 250, those two angles would have to be congruent, and they're not. Okay? It's not an isosceles triangle, so the altitude is not going to bisect those. What you need to do is treat it as one giant triangle for a minute. Okay, so 180 minus 63 and 72 leaves what up top? 45. And again, this height is not cutting that 45 in half even. Okay, but I can now find either this side or this side over here, one of the two missing sides, and then I'll be able to find the height. I'm going to find x. So using the big triangle, the sine of 72 is across from x in the same way the sine of 45 is across from 500. I got 672.5. Anybody with me? Yep. 672.5. Now I can use this triangle, because what do I know about that triangle? If it's a height, I know it has a 90, it has a 63, and it now has a side of 672.5. I'm going to use right triangle trig, but it would be okay to use law of sines. You could say sine of 90 is across from this in the same way sine of 63 is across from h. I'm going to use SOHCAHTOA. I'm going to say the sine of 63 equals opposite over hypotenuse, just because it's a right triangle. It's about 599. So the blimp is 599 feet up. Okay? It's okay with me if we don't do 12, but what is this asking you to find? It says they measured 75 feet and it makes a 38-degree angle with a side that they didn't measure, and the remaining one is 95. It wants the length of fence you need to go around. So what do you have to find? Yes, you need to find perimeter, okay? You would have to find that missing, oh, pretend that says perimeter. Find this missing side, okay? You find this angle first over here, right? Yeah. Gonna have to find this angle. Then you can find that angle. Okay? Then you'd find the perimeter. Now, okay, your exit slip out the door. What if it says you need 5% extra fencing? And add it back on, right? Is there... Exactly. You could also say I need 105% of the perimeter and just multiply the answer by 1.05 and it'd be done in one step. That's on worksheet 21. All right.